This is how you do initial testing of any of my water heater controls. You can have a power supply or use your solar panel, and you come in and place a 40 to 60 watt bulb in series with the positive lead going to the capacitor bank. This would be a typical capacitor bank. I only have two connected, but you can see I come in with a pink wire through the lamp, and then I come over and power the capacitor bank. Here's the negative lead. Now this orange wire that goes right to the heating element, and the other side of the heating element is a gray wire. The gray wire goes to basically the two FETs. We have a jumper across this one, and these FETs will switch on and off, and that current will basically go through the board, through the FETs, to this terminal right here, which is the negative lead going to back to the capacitor bank. We're measuring the voltage right here. That's on this meter, and regardless of where you set the voltage on the capacitor bank, you'll see that the voltage across these two terminals always remains the same. So the reason we have the light bulb is that we want to simulate a low level light condition. We don't want to have a lot of power that could totally turn on these two FETs, and then we wouldn't be able to see what it's regulating at. So we use the light bulb as a dropping resistor. This resistance is much higher than the heating element, and what this board is doing right now, it's sending very little pulses, they're high current pulses, to the heating element, but the average duty cycle is very low, but it's enough to drop the voltage on the capacitors. When you have a power meter, you're always measuring the voltage of the capacitor bank, not the solar panel, but the capacitor bank. So don't connect it before your thermostat or this light bulb. Normally you would have some resistor across the thermostat. You place the thermostat directly in series with the solar panel, and you need some little resistance to make sure these capacitors are always at the proper voltage. When the thermostat opens, this circuit will immediately detect the voltage drop, and it will turn off the FETs, and then it'll turn them back on just to maintain the voltage. So you're turning on and off with the capacitor very close to what the capacitor bank is at in the solar panels. You're keeping it under 30 volts so you don't have arcing. But as you can see right now, we're able to test this at, I'm only doing it about 200 milliamps. And you can see you can go from 49 volts up to 64 volts. And this allows you to actually initially test this thing. You may have the wrong values for this resistor that sets the voltage divider for that 2.5 volts, and you could be dropping the voltage very low on the capacitor bank, and this sort of protects you. You're never putting that much current through, and you can see what it's actually going to settle at, and so then you can play around with these values without getting into a high current situation. This is how you do the testing, and I normally specify, between a 270 and 1,000 ohm resistor across this thermostat where this light bulb would be. And if you have your initial voltage divider wrong, instead of having less than 30 volts, you could have a full 60 volts across it and just burn up your resistor. So it's best to test with a light. I don't like lights being in there permanently, because turning on and off the thermal shock or just resistance in the contacts could open up the circuit. But for short-term testing, this is the way to go, and then you can later put in a proper value resistor across your thermostat. But just remember, the light is in series with the power coming in. The voltage meter of your power meter is across the capacitor bank, and the heating element connects to the heating element from the capacitor bank, and the lower side of that heating element goes to the FETs.